Hey, and welcome back to Gaming for Tokens. I'm Marshall, and in this episode we're going to be talking a little bit about materials and shaders and textures and models and how all that artsy stuff kind of works on a base fundamental level. The first thing I want to start talking about, though, is the difference between those things, because a lot of people I notice in some circles, they use some of the terms interchangeably, and that's kind of bad. So, for example, you'll see people saying something like, "Oh, the texture is stretched over here," when really what they should be saying is these UVs aren't properly smoothed or whatever. We're not going to be talking about UVs today, but that's kind of the sirens, fun stuff. Living in downtown Seattle, it's great. But anyway, sorry about that. So some of the terms that people use, they use them poorly, and I would like to clarify that, I guess, as best as I can. So there are basically three things in Unity that you have to worry about. There's textures, shaders, and materials. Materials and shaders are very close to being the same thing. Technically they're very different, but from a beginner user level standpoint, they're practically the same thing. So if we go ahead and create a box, we will see that it has a material in it. It has a default diffuse material in it that we can't edit because that's the default material that is on everything. Ooh, more sirens. I don't know if you guys can hear that, but there's something going on. Anyway, so what you'll see is that as we look at this and as we turn it, there are it shades differently, right? So we can see all the individual faces and facets of the box. We turn the lighting on, and I make a directional light, bloop, and I put hard shadows on that bad boy. Then we can kind of see how this looks kind of like it's 100% smooth drywall almost. It's not a very exciting material, but it is a material that it's known as a Lambertian. What is it? It's known as a Lambert material, basically, in a lot of engines. It has a Lambertian smoothness to it, which means that it's rough. But it's not visibly rough. It's kind of like very, very, very finely sanded wood, or like I said before, drywall. Or it's rough because it's not shiny, but it's not so rough that it doesn't appear to be smooth. It's very, very. It's kind of an odd thing to think about, but that's basically what this is. So that is all of the things that I just described this as. I'm talking about the shader specifically, right? The material that it has on it is a default diffuse, but that default diffuse you'll see over here has a shader that is diffuse. The material, think about it like a visible front or interface for the shader. It's not a material and a shader aren't the same thing. A material is just Unity's face that it puts onto a shader. A shader is nothing but code. As a matter of fact, I believe, well, there are shaders in here somewhere. They're going to be in standard assets or somewhere. I don't know where they are. But there are shaders, and we will be looking at a shader, hopefully, if I can muster one from the files on my computer. So we're going to go ahead and we're going to create a new material here. And you just create it just like you do anything else from the Create menu. And we're going to name it New Mat, and we're going to drag and drop this onto this cube. Now we'll not notice any change because whenever we create a new material, it defaults it to a diffuse shader, which is the same that we used to have on it. We'll notice that the new mat is in this new slot, but it still has this diffuse shader that it's using. So the shader is the same as the default one, so we don't notice any change. You also notice that I can edit the new mat here, as well as if I select new mat in the project window. Doing those is the same thing. You can edit it on the object, or you can edit it not on the object. It's up to you. So some of the things we can do on this, we can change the color of it, which Unity is just being great today. It is bringing stuff over to my other monitor. There we go. Okay, sorry about that. So we can change the color by clicking on the little color thing here. We can also eyedropper if we want. So if you're pulling stuff from the background or whatever, you'll notice that it's changing color. So if I select that, then it's that color. Now we also have a color picker here, so we can say we make it green instead if we want. That's fine and dandy, and usually works pretty well for any kind of white boxy design stuff that you want to do. Just putting diffuse shaders on things, or diffuse material shader combos, and selecting colors and splashing color around. It usually works just fine. But if you want to get a little more artistic with it, you can import shader or textures into your materials. You just plug them in by either dragging and dropping them onto this box here, or by clicking the select button in that little window, and then it brings up a list of all of the textures that are imported into your Unity project. So if I choose this one, for example, the default particle texture, I get this. Now, the reason why it's green and not white like the texture shows is because we have green. By default, this should usually be always white. If you're using textures, that color thing should usually be white. Unless you're trying to do something weird with like team colors, which you see sometimes, so like red team, blue team, green team. They all use the same textures for all those different models, but they use a different color. Like now it's red team. It's that easy. It's just a different material using the same shader. So that's where things get weird, but we'll get there. So if we want to use a different material, then we have a different material. This is the, I believe, the construction guy, Unity default construction guy for the third-person controller. I don't know if I've shown you guys that or not yet, but this is the textures for that guy. But anyway, so yeah, putting textures on something is really, really easy. So far what we're seeing here is we're seeing that this is the material, new mat, right here. Inside of that, we have a shader selected, which is diffuse. And on that material, we also have plugged in a texture, which is here. There's more than one texture in there, so we'll get to that in a second. But first, let's select a different shader. Let's get weird with it. So if you click this little drop down, we have all of the different shaders in Unity, and a lot of them are more or less efficient than others. So like the diffuse shader is probably a pretty normal basic shader. It's not going to be too high cost. I mean, it takes a texture and a color, and that's basically it. But if we did a bumped diffuse, then what that means is that it takes a normal map right down here, so it takes two textures. So if we then select the construction normal map, as we look around on this, we'll see that now it has wrinkles and things. So just as a compare, oh, look at that face, yeah. So if we hit none, this is what it looks like for without any normal map on it. And if we hit the normal map on it, suddenly it has depth. It has ins and outs. Some of you may know this is a bump map. Bump maps are kind of an archaic term. That's what they used to use, like maybe 10 years ago. Since then, they've pretty much solidly switched over to using normal maps, which are very similar to bump maps, except because they use three colors. They use R, G, and B, and bump maps only used black and white. I might be talking a foreign language here, but basically bump maps were a black and white texture that white signified as high as it possibly could go, and black signified as low as it could possibly go. And you used variations of like grays in between to get different varying heights. The normal map here, which looks in this instance like that, uses three channels of color. It uses red, green, and blue for it uses blue for height, I believe, and it uses red and green for direction, so it can actually sense where like what direction something is coming off of a material, so off of a surface rather. So for example, on this guy's wonderful face, you'll see here that this actually looks like it's coming off in that direction. On a bump map, this would be coming straight off of the face. It wouldn't be coming off in any direction at all. So it's a subtle thing, but it's a thing that makes a huge difference in the way that we perceive the simulation. I'm trying to get a close-up on this thing. Here we go. So the stitching, for example, you'll see how like this looks like it has a direction to it because this wavy piece of cloth comes over in this way, and you can see that it's dipped here and is raised here, and it's moving in this direction kind of. And you'll see that the stitching kind of goes over it and around it. That kind of thing would not be possible on a bump map. A bump map would either be like up or down. It's not up and a little bit left and then a little bit right. It's up or down. Anyway, so that's kind of my spiel about normal maps. So going back to our materials and what things are, we have selected a new shader, and then we've plugged in a new texture into that, and it's all on the same material. So again, a material is just a front for a shader. Our material hasn't changed at all, but our shader has, if that makes sense. So if we decide to put a different shader in, like a specular, then we have kind of a... Here we go. Alright. So I'm going to turn the lighting off on this. There we go. Cool. So now I've put in a shiny shader on this. So as we look at it and as we like spin it around, we'll notice that it gets shiny or not shiny depending on how we're looking at it. Or rather, it's reflective or not as we look at it. And it's not actually truly reflecting. This is just like, think about it like a brushed material or a brushed metal. We get it'll be glossy, but it won't be reflective. Reflective materials are a whole nother thing, and they're actually really tough to do in Unity specifically for some reason. They are here. Here's a reflective, so if we do bump diffuse. But the thing is, we need a reflection cube map, and cube maps are kind of an odd thing to talk about. I will end up talking about them at some point in this video, but they are kind of an odd thing to talk about. They're kind of like a skybox, if you know what that is, which I'll be talking about skyboxes hopefully too. This is going to be a longer video, by the way, because there's a lot of stuff that I'm talking about. I might split it into two, but I don't know. So anyway, so these are the different shaders. You can mess with these in your free time. There's a lot of cool stuff in here. The unlit texture I use fairly often for things. It basically just means that with lighting on, lighting doesn't affect it. So like if we create another cube, we'll see that like clearly the lighting is affecting this because like we have our directional light in the scene pointing that way. So over here is darker, but this cube doesn't care. It's really, really handy for certain things. If you get good textures and stuff on things, and you can actually like you can paint your textures well, then it's useful for certain styles. What else? There's transparent. This is kind of important. So if you do a transparent diffuse, it uses the alpha map of the texture, which if you don't know what that is, I'm terribly sorry. But it uses the alpha map of the texture to gauge transparency on the object. There's also transparent cutout materials, which are similar to cutout diffuse, except they are either 100% there or 100% not there, and you can gauge that by the alpha cutoff, by how much you want to cut off. And there's also, again, there is a main color on this with an alpha slider, which does dictate something. It dictates, in this specifically, it dictates the amount of cutoff effectively, but it's kind of like a secondary slider for it. So if, for example, if we went transparent diffuse and then we drag that alpha slider down, it would actually make it gradually go away. See? Because the alpha diffuse is there to varying degrees, if that makes sense, but the alpha cutoff isn't. It's only there 100% there, 100% not there. There's all sorts of these. And you shouldn't break anything by playing with these. They shouldn't like crash Unity or anything, so go nuts. But yeah, there's a lot of stuff in here. I end up using a lot of the particle materials as well for effects and things like that too. But Yeah, so basically the ones that you need to concern yourself with the most at the moment are probably going to be diffuse, bumped specular, and bumped diffuse. So we're going to go back to our diffuse for now, and I'll keep that on there. So I wonder what happens if we hit edit on this. Open compiled shader. So like I said before, shaders are just code, right? And a material is just a front for that code. I don't know shader code. I'll be the first to admit that. Shader code is one of the places that my knowledge is a little lacking in. I've always wanted to get into it, but I've just never taken the leap, I guess. I mean, I've opened it up and I've read it before, but I've never made it. But this is what shader code looks like. It is very, very different than C#, which is what we've been looking at. But this is the diffuse shader, right? It uses vectors. It uses, I don't know what binds are, vertexes, normals. I don't know. But we'll see here that here's the two variables that we can edit. So if we drag this over and I select my cube again, and we go back to that, please. There we go. We'll see that underscore color and main text here are our two variables that we have over here on the side, main color and base. See how it's called base and main color, yeah. So we can kind of sort of read this as long as we're not, well, like this gets kind of arbitrary, but you can read some of it for the most part. I'm trying to show you guys a good example, and I'm not finding any in this one. I've seen other shaders that are written much better than this. We'll also see how long this is. This is the scroll bar. It goes for forever. So there's yeah, 26,000 lines of code in this compiled normal diffuse shader, which seems a little insane for me. A lot of the shaders and stuff that I've seen, that I've downloaded and played with and authored on my own, which I have authored shaders without coding. We'll get to that eventually, maybe in another video. They're usually not that long, so it's not that intimidating. Just the ones that come with Unity are that long. Anyway, so that was just showing you that shaders are code behind the scenes, and then a material is just a front for that shader, and kind of a face to plug things into, like textures. So I'm going to do a thing now. I've prepared a Unity package of an asset that I made a while ago. It's kind of an old asset, but if we import new package is what I want. Import package, custom package, and then I import this. I don't know if I've ever actually done this process on here, so this will be a good thing to do. I'm pretty sure I have, but just in case. So I went ahead and you saw what I did there, I hope. Here, I'll do it again. I right click, I say import package, and I go to custom package, and I select the package that I want, and it comes up with an import package window. A package is basically just like, think about it like a compressed archive, like any zip file or any RAR file or whatever. That's essentially all it is, but it's Unity's proprietary format for that, because it holds specifically Unity packages and relates these to a file structure. So you'll see here in the thing it says underscore, under the items to import, it says underscore models / cleaver. That's going to go into this models directory over here on the right, because that's where it says it's going to go. And textures, all these three textures are going to go under where textures should go, which is here. So this is utilizing the file structure of this project to filter these into the correct folders, as well as being a zipped archive that's one folder. So if you need to, say you have an artist on your team and you're doing code or you're doing design, they can send you this package over that has all of these objects in it. It's a nice one file, it's compressed, and then you can just extract it and everything goes exactly where it needs to go. Everything is connected like it needs to be. It's very, very handy. So anyway, we're going to go ahead and import this package, and it's going to extract everything, and ignore. Okay. It came up with an error on my other monitor, but we'll figure it out as we go. So it imported this model in. This is the model. It's a rusty old meat cleaver that I made a long time ago. And something to note, when it imports models in, they come in at 0.01 scale. So if you made them in whatever 3D modeling program you're going to go into, which, by the way, this is a good time to mention, I am eventually going to do a 3D modeling in Maya video, or well, video series rather. It'll just be a little while, I think. But anyway, so when you import things from a 3D program, they may or may not be built to scale. If they are built to scale, then you can, and by built to scale, what I mean by that is built to the proper units measurement-wise that Unity uses. So if Unity uses centimeters, then this thing is actually built to be, you know, however many centimeters long it's supposed to be in the real world. And if that's the case, then you should put this to 1, not 0.01, and hit apply. The reason why it defaults to 0.01, I think, is because a lot of programs by default, like other engines and things like that, use meters, and Unity uses centimeters. So, or something like that. I don't remember. Anyway, that's why the scale is different, is because it's Unity knows that it's different than other engines, so it tries to compensate for that. But I mean, if you're used to working in Unity, then it just kind of trips you up sometimes. So anyway, once you have that done, you can just drag and drop this over, and there is the model. Yeah, so it's Cleaver. Now you'll notice that whenever you import a 3D model in, it comes default with a folder for materials and a material inside of it. By default, this material is probably going to be a diffuse, unless the model comes with materials, and that's a whole other thing. But then usually it'll just be a diffuse unless you specify otherwise, and if you specify otherwise, then you know what you're doing, and you know what you're doing. So, anyway, we're going to go ahead and we're going to create a new material for this thing, because while we have one here, this is going to act as our default material for this object. I would like to create a new material in the correct location and delete the original. So we're going to call this Cleaver_metal. And we're going to drag this onto our metal bit. And we're going to duplicate this by selecting it and Control D. And we're going to rename it to leather. Cleaver leather. We're going to drag and drop this onto the leather bits. So you'll notice that a material can share multiple objects. It is now on, if we open up our Cleaver object here, we have cord. We have the cord here. Oh yeah, and this thing is, I forgot to mention, this thing has a rig in Maya so that I could pose this thing differently. It's supposed to be a knotted leather cord hanging off the handle. So if it was going to be posed, like, originally this thing was going to be stuck into a stump. So it was gonna, this thing was gonna have to hang down, and I was gonna maybe do a little animation with it swinging. But, so this thing is rigged. That's why the file structure on this is all wonky, and there's all these like cord 1, 2, 3. These are bones. I don't know if I want to talk anything about rigging more than this is rigged, so it looks messed up, but it's not. I promise. It gets kind of weird. But anyway, so we'll notice that the cord here has the Cleaver leather, and so does the handle leather. Has the same material on it, because eventually they're going to be using the same material. They're just, because they're the same. They are the same material in the fiction of this object, right? They're both leather, so they should both use the leather material, if that makes sense. And this one uses a separate one because it's metal, so it should be using a separate one, right? Anyway, so now that we have a new material on here, well, what kind of material do you think we're going to pick? We're probably going to pick a bumped specular, I imagine. But for this one, we should probably be picking a bumped diffuse, because it's leather. It shouldn't be using. It's not shiny necessarily. This is shiny and this isn't. What you'll start to see is that depending on the object and depending on how you want it to look, everything should kind of sort of have a specular channel. That's going into kind of an artsy debate, and it depends on the style, really. It does. But for purposes of this, I'm going to go bump specular and bump specular, and there is a reason why I'm making two materials still, even though they're using the same shaders. You'll see why in a minute, I think. So anyway, once we have that material on there, we can start to look at our textures. So this is the diffuse texture, the normal texture, and the specular texture, which is something that I haven't mentioned yet. And you'll hear me probably use the term texture and matte, or texture and map, MAP, interchangeably, because a lot of the industry does. This is the specular map, normal map, diffuse map, map and texture are basically the same thing. So when we're looking at our diffuse texture here, you'll notice that over here on the import settings, there's a bunch of different wonky stuff that you might not understand. So texture type, well, it's a texture, so it should be texture, right? Like that's texture type is texture. Not necessarily, because our normal map here imports by default with texture as well, but it should be a normal map. It shouldn't be a texture. So we should change that. And do we want to import it from Grayscale? No, because it already is a normal map. So that sounds kind of confusing. Unity by default will convert bump maps, what I was talking about earlier, the black to white, from a... it'll convert those from a bump map to a normal map if you want it to. It'll try to do its best. Usually those don't look that great, but it's good for quick and dirty normal maps if you need them. We don't want to do that because this is already not black-white. This is it's not grayscale. It is a normal map already, so we don't want it to try to convert a normal map to a normal map, thinking that it's a bump map. That'd be really, really bad. The wrap mode is repeat. What that means is, so if we go to our, oh yeah, we're gonna hit apply on that. Okay, so if we go to our new mat here and we look at this as if it were a cube, and we go to the offset here and we put this at 0.25, we'll see that it starts to go over there, right? It starts to like go right. See how it wraps around? That sounds familiar, doesn't it? Wrap around. So if we go back to here, we'll see that the wrap mode is repeat, which means that if we offset that material around, it will assume that the texture over here on the left side will carry over for the right side, and the right side will carry over to the left side, top to bottom. We don't need that because we are not going to be doing that with this, so it's better if we just clamp it off. What that does is because Unity's rendering engine will by default kind of fuzz this edge to make that work sometimes. Because of the filter mode here, it'll fuzz the edge, which we'll talk about the filter mode in a second. And that could look really bad for anything that you have unwrapped to the edge. So like you'll look at the diffuse map here and you'll see that over here on the very, very, very far right side, I have some stuff going on there, and that could really mess with that. It could also mess with some of the stuff down here and over here, and yeah. Oh, and by the way, I will mention, I know I'm not the best artist in the world, so please don't try to judge me on my artistic abilities. I try. But anyway, so yeah, that's the diffuse. Well, that's the wrap mode. So we probably, for all of these, we want those to be clamp. And yep, so that one's clamp, and this one's going to be clamp as well. All right. So what is filter mode? Filter modes are... So a point filter mode means that it won't filter it, basically. You usually want to use that for stuff like pixel art. I wish I had some decent pixel art that I could throw in here and show you guys. But basically point means that it'll show every pixel. It'll be 100% pixel perfect, basically. Bilinear means that it will blur it by 1 pixel, I believe. So everything will be it'll be a little fuzzier, but it'll look better if it's supposed to be like realistic, because it kind of blends the textures together in a believable way. And trilinear just means that it blends it more accurately. Think about these like a kind of a quality setting, I guess. I don't know, that's probably a bad way to describe it, but if you do a trilinear blur on something, then it'll a trilinear filter on it, then it could look good. But if you're going for like a retro style, then you probably just want to go with point on everything. I don't know. Bilinear usually works fine, and it's usually the default for textures, so it's up to you. Aniso level, I don't really know what that is. I always forget what that is. I've looked it up before, and I knew what it was at one point, but I usually just don't touch it. It doesn't really bother me too much to not mess with it. Max size is important, though. If this is like a texture for a character model that you're going to be seeing all the time, like in a third-person game, you probably want to crank this up to as high as the texture was exported as. So 2048, 4096, probably good bets. 1024 is... so again, this is the size of the texture. This isn't the size of... it's hard to describe, but basically, the higher the texture, the more the detail, right? And whatever you painted your texture at. So I painted these textures specifically. I know I did. I painted them at 2048 because I wanted to downsize them to 1024. Things always look better when you make them smaller than when you make them bigger. So I knew that going in, so I made the texture bigger so I could downsize it. So I could probably downsize it to 512 and I wouldn't notice much of a difference. We can run with that. But for a character model, you're going to want to paint it at like 4096 and maybe down-res it to 2048. Maybe. You could run it at true resolution, which is 4096. It could get a little heavy at that point. By heavy, I mean it could be bad for performance, but if you're not running too many things at that size, you should be fine. So I'm going to go ahead and hit apply on this, and I'm going to go down my list of textures here, and I'm going to set them all to 512. Okay, so then there's the format down here at the bottom. This compressed is usually your best option. It just means that it's well, it's compressed. It doesn't take as much performance, and it doesn't take as much space in the game. If you go 16 bits or true color, it's just you're just increasing the quality of the thing, and you're making it heavier for the system to run. You're making it less friendly for the game to be able to run it. And personally, I don't know that you're gonna want to do that with anything. I've done it a couple times with like UI textures, things that I've wanted like 3D UI assets in the game and stuff like that. But usually you don't really want to touch it for 3D models and stuff. Compressed usually works fine. Like I said, unless you're running that like really high res, beautiful third-person character model or whatever, you shouldn't need to touch this. So yeah, the other types of textures that you have here are normal map, which we talked about, GUI, which is interesting because it eliminates a lot of the options. So yeah. Oh, and I guess I never talked about what those were. So alpha from grayscale and alpha is transparency are interesting things. For the purposes of this, I'm going to ignore those, but basically these will, the alpha from grayscale will, yeah, like the tooltip says, generates texture from alpha, so it will create an alpha channel for this. And alpha channels are, so this is my alpha channel for this, and there's a reason why it looks like this. And if you know anything about Photoshop and painting in Photoshop, you might know what an alpha channel is. If you don't, I'm sorry. I might do a texture thing eventually for creating your own textures, but just know that there's a red, green, and blue channel to things, which is what this little thing here signifies. This is what the red, green, and blue channels mixed together looks like. And then there's also a fourth channel called alpha on some textures. And I created this one with an alpha that looks like this for a very specific reason that we'll get into in a minute. But basically what it is it's a black to white texture that dictates usually transparency. So if it's white, then it's there. If it's black, then it's not. And if it's some variance in between, then it's some variance of there in between. So if something is gray, like right in here, it'll be partially transparent, whereas if something is white, like this line here, it'll be all the way there. And if something is black, like this splotch up here, it'll be not there, if that makes sense at all. So kind of in our transparency thing that we looked at before with the box, this is a visual representation of what a texture could look like that has transparency on it. But anyway, this just means that it'll generate alpha from grayscale from the RGB channels in this. It'll flatten that to a black and white image and then create an alpha for the image that is that. Sometimes it's what you want, sometimes it's not what you want. Usually it's not what you want, but yeah. Alpha is transparency is odd to me because that's usually defined by the shader, but I guess you can... So there are certain image formats like PNGs and stuff that actually have transparency baked in. I think that's what it's saying. I've never really used these options because, like I said, I do everything the way that you should do it, which is not automated, I guess. So anyway, yeah, that's what those are. So that was kind of an aside. So there's GUI, which you should be using for like UI textures and things like that. There are sprites, which that's what the 2D engine for Unity uses. It's relatively new, and if you're doing like a Mega Man type game, then you would use your sprites for your textures instead of textures. And the thing with sprites is that they don't. The filter modes on these are a little more interesting, and you can define multiple sprites from a single texture sheet. Yeah, it's kind of confusing, but I'll talk about that more when I go into the 2D stuff, which I will be making a video on eventually here. But so that's kind of what a sprite is. Cursors are, you can import custom cursors, and you can set these in the player settings, I believe. Edit, project settings, player settings. Yeah, sure, apply it. Why not? It's not what I want it to be, but we'll change it. So yeah, there's a default cursor, and it's just a texture 2D that you assign here. So if we, assign that, and that's going to be our texture for the game. See, or a cursor for the game. Sorry, which looks really stupid, but I mean, it's something you could do. Some people like custom cursors for their games. I've never seen the appeal, but I don't know. Maybe I'll do it eventually. So anyway, you can define it as a cursor. So there's a reflection. So this is kind of confusing, and there's a huge tooltip on it. So before, when I was saying that there were reflective materials, but they're kind of confusing and kind of hard to talk about because they use a thing called a cube map. You can also define it as a reflection map as well. It gets kind of weird because basically what you're looking at is a box in 2 dimensions, and yeah, I mean, it's kind of an advanced topic, to be perfectly honest. Sorry, but it's kind of weird. Like, you have to define, if you know anything about 3D mapping, like UV mapping, then you'll know that it's going to look like a box. So there's going to be like a box here, a box here, a box here, a box here, another box up here, I think, and another one down here. And then you have to like fill that in, and that's what that's what the object is going to reflect around it. It's really confusing. It's really weird, but that's how it does. That's how games do reflection mostly. So cookies are. I have a theater background. So before games, I did stage theater, and if you know anything about stage theater, you'll know a cookie is a gobo. So it's a think about like you cut out shapes on a piece of paper and you put that in front of a flashlight. And then obviously the flashlight casts a light that is the shape of whatever object you cut out, right? That's what a cookie is. So you can import textures of cookies, and then you can use those cookies on lights. I don't know why they use the word cookie. Oh, loud motorcycle too, huh? Anyway, I don't know why they chose to use the word cookie and not gobo, but I don't know. They just did. So it's a thing you got to get used to, I guess. So a light map is exactly how it sounds. It's the light map. Typically speaking, you won't be importing your own light maps. You can. There's nothing wrong with it. I guess if you really don't like the light baking system in Unity, you can light bake in Maya or something and then export those light maps. I don't see the point, because Unity's light baking system is actually pretty good. It's gotten a lot better lately. And then there's an advanced, which is basically create your own texture import thing. But yeah, so you just get all the. So do you want to generate MIP maps? MIP maps are like, if you've ever heard the term LODs or LODs in video games, so a model will become. There's so many terms. A model will become less high or lower resolution the farther away you are from it. That is to say, lower poly away from it, so less vertices, less geometry on screen. MIP maps are the same thing except for textures. So textures will become lower resolution, i.e. smaller. So this is a 512 by 512. It could go as low as 64 by 64, maybe 32 by 32 if you let it. So the textures will become smaller and less detailed the farther away you are from them. It's a way for the game engine to save on memory as you're running the game. So that's what MIP maps are. You usually want it to generate MIP maps. If it doesn't generate MIP maps, then it won't use them, and the game will be using the full resolution texture all the time, even when you shouldn't be or don't need to be looking at it or whatever. So yeah, that's MIP maps. Typically speaking, the advanced texture is advanced, and you probably shouldn't really mess with it unless you really need to. But basically, yeah, you get to tinker with all the MIP map stuff and the import type and all sorts of, yeah. But for now, we're just going to go with a texture, and we're going to call it good. So, when we build our material here for our cleaver, so we have the metal, we're going to go bump specular, and we're going to go ahead and drag and drop our cleaver diffuse into the base. So we'll see that it live updates over here. And it also kind of shows me a preview here. I believe if I click on this... Oh, no. There used to be a way to import models into this little viewport thing here, but it's probably best because we have it over here. So, yeah, like I was saying, you can... you click this little like shape thing here, and it puts it on different shapes, so you can kind of see how it looks. Anyway, so what I was saying before was that the alpha channel of my diffuse, remember, it looks like this for some reason. It's actually the exact same as my specular channel, just without the color. Unity has a really, really wonky system sometimes with its materials, and this particular material, this bump specular material, which is a really important shader, is it uses the alpha channel to determine the gloss map, which is what I have here, the specular map. Now, my specular map actually has color information on it. You'll notice it has like the rust and stuff on the blade. Well, my alpha channel can't have that because it's only black to white. So when I'm creating my material here for my cleaver, I don't get any of that color information in the specular. It's just, is it shiny, is it not? Most modern engines will let you put color information in your spec maps. For some reason, Unity hasn't decided to go that route, and I'm willing to bet that it's a memory and performance thing. Instead of having, because again, you know, an alpha channel is one channel, so it's red, or it's black to white, so it's 0 to 255 if you know anything about colors and RGB channels and stuff. That's one map that has to, one channel that it has to keep track of. If it used a full texture map, an RGB map here, then you'll see that it has to keep track of 3, which is more expensive than 1. It's, you know, 300% more expensive, you know. Well, I guess 200% more, 300% as expensive. So, that's why it does it. I don't agree with that. I think it should have both options, but I'm also, you know, not important enough for that decision to matter. So anyway, so you'll notice that because of the way that I built my specular map, you'll notice that the specular map kind of obeys the shading of the material. If I turn the lighting on, then it doesn't, because this lighting is meh. If I increase the intensity a little, nope. Alright. Well, I'm turning off the lighting then, so we can see what's going on. So you'll see that like it's not just shiny everywhere, it's only shiny where I told it to be shiny, which is where there would be smoothing and wear on the object, right? So if we go back to our metal material here, there's a normal map still that we have to import. So there's a cleaver normal map, and you'll see that the normal map is faking the depth of the scratches and things, and it's doing a fairly decent job. I believe it's still set to normal map. Yeah. So you'll see in the specular that it helps the specular a little bit here and there, but it also so like that's a good example right there, that little crack there. If I took off the normal map, that probably would go away. Well, it's less intense. So, oh, what is happening? Something weird is going on with Unity right now. That's okay. But anyway, that's so a normal map kind of adds bump depth to the object. So like surface details and things like that. Like these scratches are a good example. You don't want to try to do something like these cuts in the blade with a normal map. Or my option was to put these ridges in the leather in the normal map or not. I chose not to. It's a personal preference thing, but that's just what I chose. So I'm also going to increase the specularity of that a little bit by making that color brighter. And I'm also going to probably decrease the glossiness so we get kind of a metally looking material. So something that looks like that. I like that. You can actually add color to the shininess. I know I said you couldn't just a minute ago. You can't add color via the texture, but you can add it through this this color option here, I guess. I think this is kind of a crappy way to go about it. Like I said, I really do believe that, because this is kind of a general wash color over the whole specular here. So everywhere that it is specular, it is this color. And I don't agree with that. I think that you should be able to have control over what color is where on the object. Maybe I'm picky, maybe I'm stuck up, I don't know. But I feel like that's the thing that should happen. And you can kind of see the... so there we go. So you can totally see the normal map at play here better than you can on the flat blade. So it looks like these cracks and stuff are actually, or the scratches are actually scratches on the Taurus there. Yeah, you can kind of see it over here too. Yeah, so anyway, I would be happy with this as a metal material. So let's do the leather. Leather is actually going to be a little easier. We just do kind of the same thing. We put the cleaver diffuse and the cleaver normal map in there. Now again, this could be shiny if we wanted it to be shiny. It's not that hard to make it shiny. We just tell it to be shiny. But the being the alpha channel of the diffuse texture here is governing how shiny that thing can be. It's not ever going to be as shiny as you expect it to be. If that makes sense. Yeah. So I don't know, that's that. So it's going to be less shiny than this thing is. It's going to be a little bit, but not nearly what the metal is going to be, which it makes sense. Like, leather is a little bit shiny. It's not glossy, but it's shiny. So we can decrease the glossiness there, and we can say that in the main channel here, we can add a little bit of, add a little bit of red maybe to change the color a bit. To see it. So this is why I wanted to do a separate material for this, is so that maybe if we wanted a different color, we could put a different color in it. So if we wanted it to be a little bluey, for example, it could be a little bluey, and that looks kind of neat. Because the blue complements the red in an interesting way, and it kind of comes out as gray. But anyway, so that's something that we wanted to do. It's something that we could do. Alternatively, we could go red with it, and that looks fine as well, because now the whole thing's just warm looking. So we can customize the look of the leather in engine. And yeah. So hopefully that's the different kinds of things, what the textures, shaders, and materials are, kind of poorly explained at best, I'm sure. But yeah. So hopefully that helps, though. In a video soon, probably in the next video, I'm going to be going over a third-party plugin for Unity called Strumpy Shader Editor, and I'll be teaching you how to make shaders from scratch, and I'll probably make a shader for this that that is what I want. Because like I said before, well, it's kind of stupid that you can't have like full range of your color, full manipulation of your colors on the specular channel because you have to bundle it all into an alpha. That's dumb. So I'm hopefully going to be able to show you how to make a shader that does that. Yeah. So anyway, hopefully this was somewhat helpful. I mean, I know that I kind of stumbled over some of it, but I will go more into models and stuff in the future, and I will be talking more about materials and things and how to make them and all that. But yeah, let me know if you have any suggestions. As always, I haven't been getting into those suggestions, and they really help me come up with topics for the next video. I didn't want to do materials and art and stuff quite yet because we were on a programming roll, but maybe it'll be useful to a lot of people who don't need to know programming stuff and they want to know more about art. Maybe that'll be a thing that will be helpful. And if so, let me know what you think. I mean, if you need to know more about a specific topic, or you feel like being critical about the video, by all means, leave me a comment. Hit me up on Twitter. However you want to get a hold of me. I'm a friendly guy, I promise. I try to be, at least. But yeah, thanks for watching, and bye-bye.